Module 10, Energy and Ecosystems. One criterion of life says that all living things need to take energy from their surroundings and use it for energy to sustain them. So where does all this energy come from? You learned that a majority of it comes from the sun. Organisms that can make their own food, or autotrophs, take solar energy and convert it into food for their life functions. Of course, some organisms can make their own food using other sources, such as chemicals, but a majority of autotrophs utilize solar energy for food production. We call autotrophs the producers because they produce food for themselves, as well as other organisms. Organisms that feed on producers are called consumers. And now we can further differentiate the types of consumers. When organisms get their food directly from the producers, such as herbivores, we call them primary consumers. A primary consumer is an organism that eats producers. Other consumers feed on these primary consumers. We call them secondary consumers. And if a carnivore feeds on the carnivore that ate the herbivore, we call it a tertiary consumer, or an organism that feeds on secondary consumers. We call each of these categories a trophic level. This is sometimes called a food chain because each link in the chain represents an organism feeding on another organism. But this chain is not a complete representation of what can happen in nature. Though the owl can feed on the snake, so can a hawk. And a mouse can be eaten by a snake, as well as by the owl, the hawk, and a fox. Of course, the plants can be eaten by a whole host of other creatures too, that in turn can be eaten by other creatures. So when you combine all the possible food chains, you get a diagram that looks more web-like, or a food web. And can you see that sometimes an organism's trophic level can change depending on what it eats? In the original food chain I showed, the owl was a tertiary consumer, feeding on the snake. But owls can also eat mice, making them secondary consumers. A food web is important in an ecosystem because it shows that the predator-prey relationship between organisms is critical. Just like the Australian rabbit story, if there are no predators to feed on a population, the population could overrun an area, devastating many other populations, both plant and animal. Notice that this food web is not complete either. It doesn't take into consideration creatures that may feed on the tertiary consumers and others. After all, there are organisms that prey on deer, hawks, foxes, and owls. It just turns out that food webs can be so complex, you just have to limit their size at one point or another. And to make things even more involved, an organism can change its trophic level depending on the stage of life it's in. For example, hawks can prey on songbirds. But did you know that songbirds can also prey on hawks? Actually, not on adult hawks, but on hawk eggs. So in this case, the songbird would be one trophic level above a hawk. We can also look at food webs to follow the path of energy as it moves from the sun to other creatures. So sunlight is used by the producer to make food. A primary consumer feeds on the producer, taking the stored energy in the producer's tissue into its body. Then a secondary consumer feeds on a primary consumer, taking that energy up to the next trophic level. When energy moves up from one level to the next, a lot of it is lost. Energy is lost each time it moves up a trophic level in an ecosystem. How does this happen? Well, as an organism takes in energy, some of that energy is lost as heat. Additionally, some parts of the food are not eaten by the consumer. For example, when an owl eats a mouse, it regurgitates the bones and fur. So the energy bound up in the molecules of the bone and fur is lost to the rest of the food web. Now, this doesn't mean that that energy is lost forever, because in God's perfect design of creation, the leftover parts are eventually used. We'll cover that in a minute. If energy is lost as it moves from one trophic level to another, then the higher the trophic level, the more energy an organism needs, and the lower the trophic level, the less it needs. Plants, being the producers, need the least amount of energy for survival. But when a primary consumer eats a plant, it only can use about 10% of the energy in it, so it needs lots of plants to survive. And when a secondary consumer feeds on a primary consumer, most of that energy is lost, so it takes lots and lots of primary consumers to feed a secondary consumer. And it's even worse for tertiary consumers. They need to eat a much larger volume of food. We can show this phenomenon in a diagram called an ecological pyramid. An ecological pyramid is a diagram that shows the biomass of organisms at each trophic level. Well, what is biomass? Well, biomass is a measure of the total dry mass of organisms within a particular region. So, if we went to a forest and cut down all the trees and plants, dehydrated them, and measured the mass remaining, we would have the biomass of the plants of that forest. Biomass can tell us how much living material or tissue is in a specific area, and an ecological pyramid shows how much biomass is in each trophic level. Here is one ecological pyramid that was constructed for an ecosystem in Florida called Silver Springs. The bigger the rectangle, the greater percentage of biomass is present. So you can see that the producers have the most biomass. And there's a drastic decrease in biomass as you move to the primary consumers. Then there's a major decrease to secondary consumers, and another decrease to tertiary consumers. This is directly related to the amount of energy lost in each level. If there was no energy lost between levels, the biomass from one level to another would be the same. But because so much energy is lost from one to the other, there has to be a lot of biomass in the lower levels for the upper levels to feed on. That's why when you look at any ecosystem, the first living things you notice are the producers. You may catch a glimpse of a primary consumer next, then it's much less likely you will see a secondary consumer or a tertiary one. There's not enough energy to support many of them. Earlier in this section, I mentioned that some parts of organisms are not eaten when they are preyed upon. Their bones and fur, for example, are left behind. But remember when we discussed an entire group of organisms called decomposers? I haven't mentioned them up until now because it's hard to show them in a food web or ecological pyramid. This is because they feed on organisms from all of the trophic levels, dead plants and consumers of all levels, as well as any of their uneaten remains. And the biomass of decomposers greatly varies from one type of ecosystem to another. But they do play a critical role in ecosystems. They are responsible for eating the parts of organisms that consumers do not eat. This way, all of the energy bound up in living things eventually makes it back into the ecosystem.